Welcome to this lesson on ionic compounds. Um, Last lesson we learned about how atoms can combine together to form compounds, and there were two types of compounds. And this is the first type we're going to look at. It's called ionic compounds. Later we'll look at molecular compounds and how they combine together. Now, ionic compounds form, and this was stated in our last lesson, but I cannot express this closely enough. They form when a positive ion and a negative ion bond together. Okay, and this is also quite evident with two other regions of the periodic table, in that all positive ions are metals. So there are no nonmetals that form positive ions. And the opposite is also true, which is all negative ions are nonmetals. So if you look at your periodic table, what we're saying here, and I'll bring up my periodic table, is that these elements over here on the far right, upper right of the periodic table, they are all the nonmetals. They will always form that negative ion, and they will always bond with the blue ions here over on the left and in the middle. And that is just the nature of how atoms combine when it's an ionic compound. So these guys carry a lot more weight in the sense that they're found in many more things. And so you'll notice, substances like carbon and oxygen, and hydrogen can fit into that category of nonmetals as well. Although hydrogen does form a positive ion, it gets its own group. Hydrogen's on its own. It's very unique. Okay. All right. So let's continue on with the lesson and learn how these ionic compounds form. So determining the chemical formula is what we're going to try to do in this. Learn how the chemical formula and how we write the chemical name. Okay. So remember, chemical formula is like, H2O or C6H12O6, which are some pretty complicated, that is glucose, a complicated compound. That's the chemical formula. We're going to learn how to do that for ionic compounds in this lesson. So to determine the chemical formula, you must determine the ions for both. Okay, you have to do the ions for both the metal and the nonmetal. And we're going to need the periodic table to do that. Okay, the periodic table is going to help us determine what the ions look like. And then we use this really cool thing called the crossover method. Okay, and the crossover method is used to determine the chemical formula for the ionic compound. And sometimes the best way to do this is just through a series of examples. Okay, sorry, I missed highlighting one word here, chemical formula. We're going to determine that chemical formula. Okay, so we're going to do a series of examples here. So first thing I'm going to do is scroll down so we can see them, and we're going to go through the process. So first of all, you need to know what two substances, what two elements that you're going to combine. And then you need to be able to make the metal ion and then the nonmetal ion. And from that, we can create what's known as the chemical formula. And then finally, we will come up with the name for each of these things. So we'll write out how the name works. And that is not that difficult as well. It's fairly straightforward. Okay, so to start with, I'm going to do sodium, and it bonds with chlorine. Now let's look up these two substances and find their ions that they form. Okay, so we'll start with sodium. Sodium is Na. It's found right here. And the periodic table tells us that its most common ionic form is +1. In fact, that's the only one it does form. Okay, so we can go back to our table here, do this step by step, and I can write in Na, pen on, Na, and it's +1. Okay, and then it's going to bond with chlorine, and you'll notice that chlorine is the nonmetal. Okay, so sodium clearly the metal over here. Chlorine is way over on this side of the periodic table. It's the non-metal. So it's -1. And you can see the -1 here in the upper right or upper left corner. For those of you who maybe can't see that, I can zoom in on this really closely and you can see, just let me move my periodic table around and we'll see this. Maybe now, I'll zoom in a little bit more even. I'm not going to do this every time, but you can see right here now that that's where the -1 is. Cl is the chlorine. Okay, so we do that. I do that here because, normally we'd have a piece of paper with our periodic table on it and we can look at that very clearly. Okay, so we're back to our full-size periodic table, and I can even on my small screen see the numbers quite clearly along here for the most common charges. All right, so we go back to our worksheet, and we're now going to put in Cl. Of course, it's going to jump on me here. I should have known better. Cl -1. Okay, so that's what I'm going to put in here. Cl -1. And then we use this really cool technique called the crossover technique. Now we do not need to use the plus and minus when we're doing this, but essentially what happens is this +1 comes over and becomes a 1 here, and this -1 comes over and becomes a 1 here. And so you'd think you'd write it as Na1Cl1, but in fact, we don't need to do that. Ones don't need to be written. It's assumed if we're writing Na, there's at least one of it. So therefore, we don't even need to write one. So we just simply write NaCl. And that is our chemical formula because we're going to have one Na combines with one chlorine, one sodium, one chlorine. Okay. And to write the name, when we write out the full name, we write out sodium. And instead of write sodium chlorine, we always change the ending to "ide." CHLOR, chloride. Now, it's not always exactly obvious where the "ide" goes and what it replaces. So, in this case, it's chlorine, and we've changed it to chloride. And you just get rid of the N and E on the end and add the IDE, and away we go. But if you kind of screw up the spelling of that, I'm not going to freak out on you. The important thing is you understand that whenever you're doing a ionic compound, that you write it as an IDE, IDE on the end of the non-metal only. The sodium is unchanged. It stays exactly the same. Now, keep in mind that when we move to name molecular compounds, these rules change, and so you will see some changes. So don't assume that it stays the same for those. All right, so now we're going to move on and do calcium and nitrogen. So we need to do some additional, more interesting ones just to give ourselves some experience to see different ways that these metals and non-metals combine. So calcium over here is +2. And nitrogen way over here is -3. So you just need to remember Ca +2, N -3 off of this sheet, and we can write those down on the chart over here. So I'm going to write in calcium +2 and nitrogen N -3. And if you're not sure about these, go back and forth from your periodic table to your worksheet. It's much easier if you have printed copies than you have to flip through screens, in my opinion, but that's just the nature of how it works, okay? Now we're going to use the crossover technique, okay? In both cases, we're not using ones, so the numbers are actually going to stand. They're going to stay in place, which is good. I did a really easy 1, 1, 1, and now a little bit trickier one. So what happens is the 2 is going to go over to the nitrogen. And the -3 is going to bring a 3 over here. And so we're going to end up with Ca3N 2. What we're essentially saying is that we're going to have 3 plus 2's. What's 3 times 2? Well, that's 6. So there's going to be 6 positive ions, 6 values for the positive. And over here, we're going to have 2 nitrogens, but they're each minus 3. So that gives us 6 as well. And so we have a balance between the positives and the negatives. And that's what creates our chemical formula, makes it balance out. And now when we write this, the metal, just written normal, go to the periodic table, copy it down, no reason to spell it wrong. Calcium, okay? Not sure how to spell it. Remember, it's right there on the periodic table, right there, calcium written in. I know it's a little tiny. Zoom in, get your spectacles on, read it, okay? And then when we write the non-metal, it's a little bit trickier, I agree. It's nitrogen. Well, usually it's then referred to as nitride. So I'm going to change it to "ide" on the end. No, so if a kid writes nitrogenide, I don't mark it wrong, but technically it's nitride is how it goes. So we drop the ogen and we add the "ide" on the end, okay? And it's calcium nitride. And you might screw up a couple of these because you're not familiar, but as you use them and become more familiar with it, you will find, oh, it's not so bad. I know that nitro is not nitrogenide, it's nitride, and that's okay. But if you make a mistake here or there, I'm not going to be upset because I'm really just looking that you put the "ide" on the end, okay? All right, let's move to the next one. Let's scroll down, just scroll my page down a tiny bit, move my cursor into a place so that it won't jump on me. And magnesium and bonds with oxygen, okay? So how is this going to work? Well, let's take a look. Magnesium is +2. Oxygen is -2. Oh, that's interesting. A +2 and a -2. Well, here we go. Magnesium +2, oxygen -2. Now, using our crossover technique, we would think that we bring a 2 here and we would bring a 2 here. But in fact, remember, we're trying to balance the pluses and the minus. And because these are both +2 and -2, this is like lowest terms. We can cancel these to just ones. And this is one of the trickier things, is because 2 and 2 kind of cancel each other out. So we have a +2 and a -2. So we only need one of each. We don't need two of each. So we can write this as magnesium oxide. And we don't write the ones in because it's assumed one as soon as we have it there. And we are done. Just 1 and 1. And when we write the name of this out, again, magnesium is exactly the same. Magnesium. Not sure how to spell it. Look in your periodic table. In this case, it's also written right there for you. And then it's going to be oxide. And so in this case, the gen gets thrown off, and it's going to be OXIDE. You've probably heard of oxide before. And so it's just OXIDE. And again, we've added this "I" to the end. Magnesium oxide. And that's your chemical name for it. This, of course, magnesium oxide, MgO, is the chemical formula. All right, let's move to another one. In this case, potassium bonds with phosphorus, okay? Oh, 2P, which ones? Oh boy, I better go look these ones up on the periodic table, okay? So potassium is right here, and potassium has a +1 charge, and phosphorus has a -3 charge, okay? Potassium has the symbol of K, phosphorus has the symbol P. Probably they discovered phosphorus and named it first, and potassium came after, and so somehow he got stuck with the letter K. So let's go write those in. Potassium is a K, and he has a, or it has a +1. And then phosphorus, it has a -3. Okay. And remember, essentially what we want to do is we want to balance the positives and the negatives. And in order to balance the positive and negatives, the 3 is going to come over and go here. 3 plus 1s is going to give me +3. And so the +1 comes over here, well, just 1 minus 3. So we end up writing this as K3P. That's the chemical formula for potassium phosphide. Okay, so we're going to write that out. Potassium, the metal, doesn't change its name, just exactly the same, right? No change ever in these. And then phosphide. So again, we're ending with this prefix, IDE. You start to see this consistency all the time. Now, we dropped the ORUS and put "ide" on the end, so phosphide. Some student wrote phosphorus, phosphoride, I'd probably give it to them if they put the OR in there. It's not a problem, but eventually you will learn for each of these things what gets dropped off and what doesn't. It's not the end of the world. Now, sometimes we get these ones where it's like magnesium 4 bonds with oxygen, or sorry, this is manganese 4 bonds with oxygen. Well, what this really means is they're telling you what ion we're referring to. So in this particular case, manganese 4 can be found on the periodic table right here, manganese. And they're saying it's not the actual preferred ion, it's the second choice ion. So manganese 4 is Mn plus 4. And oxygen is -2. So we're going to go to this particular one. So I'm going to write in manganese 4, Mn plus 4, and oxygen -2. So once again, we have an interesting one here where if we just go crossover, we get 2 here and a 4 here. That'll give us 8 and 8, which would work. But the thing is if I actually only need to make the -2 so that it'll counterbalance a +4, all I have to do is add a 2 here. So it's kind of like and 1 over here. So I only need 1 manganese and 2 oxygens to give me a total of -4 here and 1 here. So I can write this then as manganese O2. I will get some students who will write it as Mn2O4, and you will get marked wrong for that. It's not lowest terms, so to speak. 2 and 4 can each be evenly divided by a 2, and so it kind of works like a lowest terms thing. So don't get caught in that sort of trick there. That's a little bit, we can bring it down. We should bring it down into its lowest terms for the chemical formula. And then when we write the name, it's simply going to be manganese out front. Manganese, funny spelling. And then it's going to be oxide because the non-metal always becomes an "ide" on the end. That's I don't know, what did I do? 5, 6 examples here. 1, 2, 3, 4, 5 examples. Okay. Now I've left you with a worksheet to do your own. There's a bunch of extra ones here to practice your skills, and I really think it's important that you go through that. We will take this up in class at some point on a Teams meeting or provide an answer sheet, but you need to practice the skill. If you think, oh, I got this, it's real easy, I suggest give it a go and see how it works. All right, I hope you enjoyed the lesson. Again, please feel free to rewind, replay, ask any questions if you are finding it difficult, and we'll move forward from here. All right, see you for the next one.